Alright, now let's go down to the second aspect that I would love to talk about on number-based system. Other operations. Other operations on number-based. In this aspect, we'll be talking about how to move from bases that are different from each other, as I've explained in the last class. So, and we'll be talking about addition, subtraction, multiplication, and division in number-based system. So let's start with this first example. Let's start with example 1. We're going to be basically talking about how to move from other bases like base 3 to another base entirely that is not very convenient to go to. So as we've discussed, the best thing is to go from base 10 first. Base 10 is like the gate of it all. So you go to base 10 and from there you can go to any other base. So 2, 1, 1, base what? Base 3. We have it to be base 3. Using the powering system 0, 1, and 2. 0, 1, and 2. So that will give me 2 times 3 raised to the power 2 plus 1 times 3 raised to the power 1 plus 1 times 3 raised to the power 0. So as we add this is the same thing as 2 times 9 plus 1 times 3 plus 1 times 1 as per n raised to the power 0 is 1. Exclude 0 itself. So we have 18 plus 3 plus 1, and this is going to give me 22 base 10. That's the fact. Note it. It will take you to base 10. It will take you to base 10. Powering system takes you to base 10. Repeated multiplication takes you to base 10. Where are we going to, class? We are going to base 8. So which means I have to use a special method to go from base 10 to other bases on 22 base 10. So we are having 22 base 10 now, and I'm still going to go base 8. So since I'm going to base 8 and I know how to do that from my previous class, so I will note that I have 22, and I have to note my remainders. Using 8 to divide 22. In how many times will 8 divide 22? How many multiple of 8 will I say 22? That's what I mean. We are used to saying that in Nigeria, so that's why I have to use that word in how many times. So I mean, what is the multiple of 8 in 22? The multiple of 8 in 22 is 2. And note it, you will have a remainder of 6. Can 8 divide 2? Yes. The answer is yes. Can 8 divide 2? The answer is yes. But in how many times? Like how many multiple of 8 do you see in 2? Then you see 0. Then you transfer the remaining figure to this way. So write your figure from the base. So I have it that 22 base 10 is the same thing as what 26 base what? Base 8. So I can conclude that hence then 211 base 3 is the same thing as 22 base 10, which is also the same thing as 26 base 8. If you should solve a work for me like this, you secure your mark. Thank you. So now other operations. We still have other operations which are like addition. We have addition, we have subtraction, we have multiplication, and the division. These are other operations that we can still discuss in number-based system. Alright, let's look at an example. That's the best thing that can explain this. Example. This example is telling us that we should calculate the following. Calculate the following in the given basis. Like the base that you're given the question is what you should run your calculation. 66 plus 99 plus 48. What are we operating under? We are operating under base 12. So note, in this case T is 10. In this case T is 10. Now I'm trying to add 6 plus 99 plus 4 8 in what? In base 12. So my result must be provided in what? In base 12. I have to show you some working so that it will sound like I'm running a magical display. So let's look at how this is done. Workings. The workings of what I'm going to do. Now, the first part here is 6 plus 9 plus 8. 6 plus 9 plus 8. 6 plus 9 plus 8, I'm sure many of you have calculated it, is 23. 6 plus 9 plus 8 is 23. And 23 is giving me a figure in base 10. That's what you should note. I am adding 6, 9, and 8 in base 10 already. So for me to get 23, you are not in base 12. Base 10 of 23 is necessary. It's important to be converted to base 12. So what will you do? Using your long division approach, how many multiple of 12 will I say 23? That's 1, remain 11, which is the same thing as E. Then this will be what? 0, remainder 1. So which means I'm having 1E as well, 23. So I will have to write my E and note the multiple. Sorry, 1E, yes, and I will note the multiple, which one is transferred to the next line. So 1, this one here must be transferred to this place. So that's for the first part of the working. The second part of the working is now 1 plus 6 plus T plus 4. 1 plus T plus 6 plus T plus 4. This is 1 plus 6 plus 10 plus 4, which is the same thing as 7 plus 14, and that is going to give me 21. 21 in base 12. 21 in base 12. If you should do that correctly, you should have this. So I'm not doing any magic right now. So it's the same thing as 21 is the same thing as 19 in base 12. 19 in base 12. So don't be surprised if I'm writing this. 21 in base 10 is the same thing as 19 in base what? In base 10. So I have to take it down there and now write 9 here. I have to write 9 here and transfer 1 to this place. You get it? I'm transferring this one, the one beside the 9. I'm transferring this to this side. So 1 plus 9, the last part of the working. 1 plus 9. 1 plus 9. This gives us 10, and 10 is the same thing as T. So if I'm writing T here, you will not be surprised. So the final answer is T9E. T9E. So the second question I would like to talk about is 5117 minus 324. You have to operate this in base 8. That's the instruction given by the examiner. The examiner says you should operate this in base 8. 5117 minus 324. Some part of it is very simple. Very, very simple. Now, 7 minus 4. 7 minus 4. That's the simplest of it, which is what? 3. I have my 3 is 8. If it is above 8 or equal to 8, there is no more in base 8. Thank God it is still lower than it. But 1 minus 2. We call it impossible, but it is possible for you to provide answer to something, and it is possible. So it is possible, but what is the approach that we go about it? Because you cannot write -1 in this system. So what will you do? You have to extract a multiple of 8 that has been added to this side. This side you have to extract 1 from it. So extracting 1 from this, you will be left with what? 0. What will now come here? The one you extract here will turn out to be 8 here, because it was the multiples of 8 that turned out to be a what? A figure here at the other hand. So 8 plus 1 minus what? 2. That's what we are heading to. 8 plus 1 minus 2. That's 9 minus 2, which will give me what? 7. So 8 plus 1 minus 2, that's what? 7. What is left here? We are left with 0. We are left with what? 0 here. So you have to borrow another one from here, which is 4. This will be left with 4. Then you bring the one that you borrowed to this location. So you are left with 8 plus 0 minus 3. 8 plus 0 minus 3, which will give me 5. I will have to write 5 here. Then the remainder here is 4. So I have 4, 5, 7, 3 is 8. I believe all of you are following me. That's good. Next question is 242 times 14 in base 5. Please listen very good. 242 times 14. I will show some working because it's a bit confusing also. The first thing here, the first line, we want to provide the first line. 4 times 2, that's what? 8. 8 is not in base 5. 8 is already above 5. For it to be equal or above 5, then it is not in base 5. So you have to convert 8 to what? Base 5, and that is 1, 3 in base 5. 1, 3 in base 5. That is how many 5 will I see in 8? That's 1. Remainder 3. So I'll write the remainder 3 here, then carry over the 1, the multiple of 5 that we have. So that means I will still say 4 times 4 times 4. The next figure, which is 4 times what? 4 times 4. Or you add what? You add 1 to it. 4 times 4 plus 1. This will give me 17. 17 in base 5 will give me 32. 32 in base 5. That is how many 5 will I see in 17? That's 3. Remainder 2. So I will add to add 2 here, then carry over 3. So the same thing, 4 times 2. 4 times 2 plus 2. 4 times 2 plus 3, sorry. 4 times 2 plus 3. This will give me 8 plus 3, which is 11. 11 in base 5 is the same thing as 2, 1 base 5. 2, 1 base 5. That is, I will see 2 5s in 11 and it will remain 1. So I will write the remainder 1 here, and there's nothing to carry it over to, so I have to drop the 2, sorry. And I have to drop the 2 here. So I will having my first line of multiplication to be what? To be 2, 1, 2, 3. Then the other line of multiplication is 1 times 2, which is 2. That's easier. 1 times 4, which is 4, and 1 times 2, which is 2. Because every figure that I just multiplied are in base 5. So adding it up in base 5 also. I think the multiplication in base 5, I have to add it up in base 5 also. 3 plus nothing. 3 plus emptiness is what? 0. 2 plus 2, that's 4, is still in base 5. 1 plus 4 is already a figure that is not in line with the rule of number base. 1 plus 4 is what? Is 5. And 5 in base 5 is the same thing as 1, 0. This is in base 5. So I will have to write 0. Then carry over the 1, which is now left with 1 plus 2 plus 2. 1 plus 2 plus 2 is 5. This is what? 1, 0 again, which is in base 5. And I will have to write 0. Then carry over the 1. So this is my final answer in base 5. Finally, the last example on this subtopic, which is the division. And that is 1, 0, 1, 0, 1, 0. standalone division method. I have 1 0 1 0 1 0 to be divided by 1 1 1. Where this thing, where you have to be careful here is that you can't just use your figure to divide the other without trying to consider which one is bigger. 1 1 1 is bigger than 1, so I can't start my division from there. 1 1 1 is bigger than 1 0. I can't start it from there also. 1 1 1 is still bigger than 101, which means I still cannot start my division from 101. Then that means I can start my division from what? 1 0 1 0, because 1 0 1 0 is bigger than what? 1 1 1. Then how many 1 1 1 1 1 1 1 will I see in 1 0 1 0? And that is going to be 1. I will multiply that 1 that I have just gotten to what? To the divisor. The divisor here is what? Is 1 1 1. On multiplying that, I will have to what? Subtract my result from this. Then notice, I would like you to do something class. Any place that the result is 0, represent it with dots. That dot will help you to notice that digit is over. For example, here now, in a situation where I want to subtract this, 0 minus 1, is it possible? It's not possible according to our normal way of assuming. It's not possible. So you borrow. By the time you borrow to this place, you have 2, because you are operating in base 2. You have 2. So 2 minus 1 is now what? 1. Then you are left with what? Nothing here. So you have to borrow again from this one to 2. Then from this one again to 2 here. So 2 minus 1 is what? 1. Then what is left here? We have 1 minus 1. 1 minus 1 is what? 0. So that's what I mean that you should represent it with dots because of this division. So when you have that dot there, then fill in the rest. Let them come down the line. That is 1 and 0. 1 and 0. You check again. How many 1 1 1 will I see in the next possible figure? I can see 1 of it in this. Then I'll write another 1. And I'll write another 1. There is a former one there. Sorry, class. There's a former one there. And I'll write another 1. On writing another 1, I will multiply it again. I will have 1 1 1. Then what will you do? You subtract. On subtracting, I have dot, dot, and dot. That is, it's giving me 0. Then with another 0. That is remaining as a figure. So 1 1 1 is 0. See what? How many 1 1 1 will I see 0? I will see 0 of it. So I will multiply 0 to my divisor. I will have 0. Then subtracting it, I will have what? Nothing. So now I can now conclude that what? That 1 0 1 0 1 0 all over 1 1 1 is the same thing as what? 1 1 0. There's another approach to solving example A to D. Example A to D. What is the method that you can use? The method is very simple. Just try to convert each number to base 10. Then operate them using your normal base 10 approach. Then after you might have gotten that, then transfer it back using your preferred method to get your figure in the desired base. Because we are compelled to operate all these questions in the given base, that is the reason why I am forced to do this. My preferred approach is what? Is to convert each figure given to base 10. Then from base 10, I can now get it back to the preferred base. So that is a very long, lengthy and a complex explanation on what? On number system. The next thing we'll be talking about is how to operate on fractional number system. Thank you.